Welcome back to David Moore Engineering. So today we've got something a little bit special for you at home, and it's one of the processes that we do here specifically on Jaguars that we felt was worth making a whole video for. So we'll roll credits. We'll see you in a sec. So today we're going to be going through line honing a Jaguar E-Type cylinder block, and this is one of those processes that a lot of engine firms do miss. That's not to say we're the only ones that do it. A lot of good firms do, but a lot of people take for granted that the main housings are straight, true, and in line. So I'm going to run a small video here that we took years ago and was on our social media. And it was so prominent, one of the UK's leading Jaguar specialists picked up on it and now uses us because of this video. So we're going to run that now. So what you can see from that video is that the housings here had cleaned up, and then down the block they hadn't touched and had then touched here, meaning that the crankshaft center line was actually low in the middle. And it is a common problem with old used Jaguar blocks. Now, one of the ways we do our Jaguar blocks here, so I'm hoping that you guys can see, if Ross can pan down, we've had this block caustic dipped, hence it looks brand new. You can see even inside the water jacket how clean this block is. So we then go on to fit the liners. Again, if we now pan inside here, you can see the new liners are already fitted to this block. Why we fit the liners first is because when you fit liners with an interference, it does stress the block. The bigger the block, cast iron blocks are better at this. The bigger the block, the less it happens. Cast iron blocks are better than aluminium blocks, but it does twist the block, which will make the problem in the line hone worse. So the way we do it, pressure test, which again, you guys have seen plenty of times, but it is a big thing here. We dip the block, we then fit the liners, we then, if Ross can come over and show you, we then clock the main housings to make it true from this point to this point, and then we reface this bottom face, or the sump pan face, or the crankshaft centerline face, whichever name you want to call it. Okay, what that means is that this is then true and in the middle of the cylinder block. So what we then do, as we line hone, it should then make the line hone in the middle. Everything should be good. You know you have a good sealing face. Everything is freshened up. And then the next important bit is if we can pull these up on the dowels. So we have to remove the dowels. Now these are quite tight, and what we do is we drill the dowels, tap them so that they can be slide hammered out, and we then grind the main caps. Again, in due course, we'll be more than happy to show more of those processes, but obviously for the length of the video that we get to realistically go through, we've sort of done that bit first, and we're going to try prioritize today on the actual line honing process. So if you guys like and subscribe to the channel, you'll be able to see more. So again, we know we ask a lot for that, guys, but it's important to us. It's a real inspiration. The more support we get, the more inspired we are to keep making you these videos. I've said it before, Russ is giving up his evenings and weekends to come and put all of this effort in for us. So like and subscribe, and hopefully we'll be able to make some more videos and show you a bit more. So now that basically what we have done is we've created a flat center line to the crankshaft. But for you guys at home that do know understand engineering, if you have a good circle and you then take some material from this face and some material from this face and put them back together again, the distance from top to bottom will be smaller, but side to side should be roughly the original size of the hull. So what that means is you now have an out of round hull. What this machine allows us to do, these are specially designed mandrels to remove out of round, and the mandrel is one unit that goes through the entirety of the block in one go. So as you look down the main bore, you'll be able to see it might look in line, but we are going to see if it's in line. So as that mandrel turns, it works by only removing material from the small point. So it doesn't make your shut line any bigger, so it remains in tolerance. So it will only take material from here. Now, the further we go and the closer to the original size we get, the hone-in mark should spread out round here. And what will happen, dependent on what the original size is, will depend on whether or not it cleans up all of the way round. So what sometimes happens is you get a beautiful machine surface from here to here and from here round to here, but you still see the original hull from probably here between my two fingers. Now, that is part of the reconditioning process. You cannot make the hull perfection in something that's already there. It's not possible. So, but what this allows us to do is make it as good as you can get it for a remanufacturing process. Also, to any of you guys that have built engines at home, and if you haven't, if you fit bearings into a main housing and you actually bore gauge them for your oil clearance, people will know, and if you don't, this should help you, that top to bottom will be the oil clearance and the bearings actually sort of taper away towards the shut line. So it's not as important at the shut line as it is top to bottom. This is a sort of well-known engine reconditioning process. So what we're going to do, we're going to set up the mandrel and sort of go through. We're going to give it a flick initially, and then we're going to come in and try to film exactly what we saw in that last video that we posted up from a few years ago, so that I can then, hopefully in this block, we'll talk through and see what this block is actually like. So we'll get the mandrel set up. Okay, so obviously you guys got to see us setting up the mandrel. You would have noticed we'd sort of set height, set the mandrel, made sure that the block was all clamped down. Not very exciting stuff. Again, if we come over here, one of the main things of measurement is, and being able to machine, is being able to measure accurately. So what we're doing here, just setting your standard. So you can see we're sort of half of a tenth out. I'm more than happy with that. We will check this multiple times throughout, just to make sure everything's happening. So Jaguar main housing size is between 2.916 and 5 tenths to 2.917. Depends how you want to set it. Personally, I like to set to the bottom limit And that is, I have to make sure at all places the needle is moving past. So again, all we do, set your micrometer to all the way out to 2.916 and 5 temps. You'll see as we get close, it can be a bit fiddly to get it exactly where you want it because they're so accurate. So 2.916 and 5 temps, there we go. And we can lock that off. So, oh no, we haven't locked that. 2.916 and 5. 2.916 and 5 temps. So you're able to see that. Now we've already inserted the bore gauge. So what we're doing here is you have to move the bore gauge side for side. Now, as you see, that bore gauge is just flicking past the 3. That means that's its smallest point. So I'm now going to set the bore gauge to roughly round here. So that looks about 3 temps. So if I now look at where it is and I move it just 3 temps, pretty happy with that, to be fair. And what I probably want to do is half a temp. And we want it to just flick on that like there. So that's maybe half a tenth past, which means if I am past the 0, I'm half of a tenth of a thou already into the tolerance. So that's the safer side of setting that bore gauge. That's fine. Now, the next steps we do need to do is obviously caps need to go on. So caps can now go into place. There's multiple different ways in which caps are located. We'll give that one a little tap down in a moment. Let's get them all in. You obviously want to make sure these have been cleaned and then just put some WD-40 over them. So there's a couple of ways that caps can be held into blocks, and different Jaguar blocks have different size dowels and stuff as they go through later iterations of the block. But you need the dowels for location, because obviously if we make this perfectly true and in line, but there's no dowels, when you undo that cap, it can move. Having the dowels means it goes back to the exact place it's machined in every single time. So once they're done and home, we can start looking at torque figures. One of the things with torquing is obviously the amount of torque you apply will change the shape and diameter of the bore. So it's important that when we machine the block, that's right. So those caps are actually sat on the stones from when we last used the mandrel. So if I wind those stones down, that will actually allow the clearance we need for them to sit home. There we go. So just want to sort of make sure that everything, I'm going to have to see that one, everything goes home. So now we tend to apply ARP grease to mains whenever we're machining or reline honing. For you guys at home that do understand, ARP grease can change the torque setting, but we know this engine builder and he also uses ARP grease. So torque settings are important, but they're important for the replication process. So What we do is we'll apply the same torque setting as the factory, but we'll apply the ARP grease, because it reduces any friction on the bolt, stops you getting a bum reading and stuff like that. So when you use ARP grease, it needs to be underneath the head of the bolt, and it also needs to be on the threads. So just for speed and to stop my hands getting any dirtier than they do doing this job, it's a lot easier to just apply it where the bolt is going to sit down and then apply it to the threads of the bolts before they go in. One of the things, and at some point we should probably do a video on this, but it's very important when you're talking about to keep the movement going. If you try to torque a bolt that's stationary, it will take more to start moving it than it will to continue moving it. So if you're not going to get a true torque reading. We could probably do a nice video on that. Pop in the comments if you want to see a video of experimenting exactly that, about turning a bolt to torque and then jigging it through. Maybe we'll do a video on that. Let us know in the comments if that's something that you guys want to see a bit of. So again, oh, there we go. You can tell it's not staged here. So again, some people like to sort of larrup this on in a bit of a lump and then just wind the bolt in. I've managed to get my hands nice and dirty there. Personally, I like a real thin, well spread out layer round the bolt. So that's one in, ready to go. A lot of this is where the time is spent. A lot of what people see in what we do is how long the machining process takes, relevant to how long you have to charge to do the job. So a big part of what we do is all in prep. The actual exciting bit doesn't take that long. So we can spend hours and hours getting a job ready, machining the bottom of the block, facing the caps, cleaning cut stuff up, cleaning bolts up, ARP lubing, putting them in, torquing them up. And then you might only be in this machine for an hour. And then you've got to take it all back apart. You've got to clean it all. So there really is hours and hours and hours that go into this sort of stuff. So now we're gonna set the torque wrench. If you guys have been following the channel, you'll know that we set a torque sequence ourselves. Jaguar blocks didn't have a torque sequence. We will at some point do a video on the exact block that we sort of come to that conclusion. So on a Jaguar, we are 83 foot-pounds, so we'll sort of divide that by 3 roughly. And so we're going to go 30 foot-pounds for the initial and tang side first. So we'll sort of go through a 3-stage torquing process. Now, me and Ross was just talking, again, I bang on all the time about how me and Ross have been good friends for nearly 20 years now. And one of the days that really sticks out to me is my first car I actually bought from Ross, which was a 1.5 Honda Civic. And back in the day, I remember going round to his house to help him strip the interior out of it to make it go faster, because that's what kids do, of course. And it was like a real distinct memory of mine of sort of encouraging me to work on cars, get involved in cars, be really passionate about it. So I want to ask you guys to comment below that sort of memory for you. What memory really sticks out for you guys as that defining point in falling in love with cars and working on cars. Who was you with? Where was it? What car was it? Let us know below. Again, if you follow the channel, you'll know we try to read every comment. And it's something, you know, we love the engagement, so keep it coming. Again, you guys are going to see we're now going to the 60 mark. So again, go back to the tang side first. Keep that torque wrench moving the whole way. So do all of the tang sides first. It just makes it nice and easy. There we go. Right, so we're now torqued up, and what we'll do, we're just going to have a rough measurement through, and then we'll do the first sort of bit of machining, and then we're going to run through and show you a bit of what we spoke about right at the beginning of the video so that you guys get to see exactly what we meant. Now, obviously, we can run the initial measurement check. So what we're going to do, again, we always check everything with 2 bore gauges. So you can see there, we're at about 5,004 because that there is 0 and we're on the minus side. So we're at about 5,004. Just to show you guys, if you twist right round towards the edge, see, this bore is technically already big at that shut line, and there is nothing we can do about it. But if we come to here, we're already small. So if Ross can show just how close to that shut line we are, there is nothing we can do about it, and we're small. When you get to the very shut line, we're actually slightly big. So now we was at 5,004. If we get the other bore gauge, we should be able to check that that's also set correctly, which again, 5,004, and on the back end where we was 5,001. That's fine. Yeah, so that's okay there. Yeah, see, it is big there still. So as we go through, again, we're at about 4.5 on that cap. We're at 5 on that cap. About 4 on that cap. About 4 on that cap. Now with Jaguars, about 5.5 on that one, and then I'm going to have to pull this all the way out to go to the other end. So with Jaguars, because they are a problem, generally speaking, sometimes halfway through the job, you have to take the caps back off, regrind them to shut the hole back up, and then go again. Again, what that can do is move your crankshaft center line relative to the center, but it's negligible. If you take 2 thou off of the caps to shut it down, 2 thou, you're only going to move the center line 1 thou. So again, not perfect, but unfortunately, we can't remake something perfect. We have to get it as good as is physically possible with what we have. So this machine, basically, one of the things we're looking for is sort of setting our stops so that the mandrel doesn't go too far back or forward. The machine is not, you know, it looks like a rather basic machine. All of the intelligent stuff is basically done in the mandrel. So we just want to sort of set our stops about there. Now these can be adjusted whilst you're honing, dependent on the results you get. So what we're going to do, we will lower this down, and you'll see that this will oil up our mandrel it helps if we turn it on, so let's get that done. But that's going to oil up the mandrel and lubricate and cool the mandrel whilst we hone the bores. So bear with me 1 second. I'm not doing a very good job of this, am I? So now we get that on, so you guys can see here, Sun'N have designed the machine really well. So this is going to come through now. So that's going to lube the mandrel as it goes back and forwards. And then as we lift it up, it's able to stop due to the pressure relief valve, carry on machining, lift it up out your way. So we're then able to sort of thrust back and forwards whilst the mandrel spins. And from here, you're able to literally just tighten those stones out. So there we go. So I'm now getting a resistance. So apply a bit of a cut. And what we're going to do, so I wanted to just do that initial cut. Normally we wouldn't bother and we just carry on going, but I want to be able to show you guys at home. Let's turn that off so it doesn't interfere with the mics. But I wanted to be able to show you guys at home exactly what we mean. This block. Yeah, So let's get in and see what we get. Because we're going for that initial bit. And what we might have to do is get in there with a mirror. But can you guys see here how it's all machined and then not machining up to here? So from here to here hasn't machined, but it has started touching here. And this is going to be a really hard one to get on camera. So Ross, can you try and show the guys here? I don't know, you need to sort of come back a bit, Ross, right? But this one here is much shinier than, as we move back, than this one here. And what that is like we said, the block has a dip in it. It's really common on Jaguars. It's very hard to be able to show you it properly on camera. I'm just hoping that you guys are able to see that. What I might have to do is we'll stop the camera in a minute and I'll try to take 2 photos where I can sort of get it and have them side by side so that you guys at home can actually see that colour difference of what we mean. So our next steps now is to basically keep going through, and that machining process is going to come further and further round so that we end up with round, on size and all in line.
One eternity later.
Now, you just got to see a bit of what happened, so we're now going to sort of explain that, because that was obviously quite a sped up piece, because it gets rather boring after a while. Again, I'm going to try and get Ross to come in here to show you guys. And what I really need is here to here. So you can see right where my finger currently is nice and shiny. Here is nice and shiny, and then there's this dull patch from this fingernail point here to this fingernail point here. Now what that is, guys, is exactly what we were saying about how you cannot get a perfect circle when there's already one there unless it's too small. If it's too small, it will make it round again and then push the whole thing bigger. So that is part and parcel of this process. And what it is we're making the best out of what we've got, because the casting and its previous machining does hold a limitation to us. So the next bit I want to show you guys is, obviously, when we initially measured this block, we had about 5-ish thou undersize, and you've seen me multiple times go through. One thing, I don't know if you guys at home could see it, but it's a bit notchy in the first process. And what that is the mandrel taking the outer round out. So the closer you get to the finished size, the smoother the whole operation becomes. So if Ross can come down here, so you can see that we're in the third main in from the back, which on the Jaguar is number 3. And if you read the clock, we're at, oh, there we go. We're at 1 thou under bottom limit. If I go to the other side of that main, we're also at 1 thou. We're now going to go to main number 2. We're at 1 thou and 2 tenths. That's fine. Where am I? Let's get her in place. So again, you can see those two are really nice. We're now going to go to the main cut number 1. And can you guys see that? We're about half a thou different. So we need to address that. We need to try and make that bigger. And hopefully we can do that by stroking further out the block. For you guys at home, as time goes on, we'll be able to sort of explain more and more. So again, we're at about 1 thou and 3 on that center cap. 1 thou and 3. We're obviously getting it really nice, and 1 thou and 2. So you can see 1 thou and 2. 1 thou and 2. Thou and 2. So you guys at home, you can clearly see that we are very much bringing this nice straight, replicating the sizes down the block. And one of the things that we have to concentrate when doing this is trying to be realistic. So there's a 1/2 thou tolerance. And for you guys at home that don't know, let me see if I can give you a replication of that. But a Rizzler paper, we'll measure one for you now so that you guys at home can see. So if I get an old 0 to 1 micrometer. No. Cancel that, Ross. Oh, right, okay. So a Rizzler paper is just over 1/1000th of an inch. So when we now go back to our bore gauge, a Rizzler paper is from 0 all the way round to 1. So when we're getting a variation across 7 main caps, and 2 sides of each main cap of, say, 2 tenths, the difference is 20% of a Rizzler paper. It's so small. I think in the next couple of videos, you guys are going to meet the guys from here. And Harry is the world's worst here, because what he does is he'll be halfway through the job and he'll go, oh, and I get really nervous. So I have to come rushing over and think something's gone wrong. And he then goes, oh, that cap is 0.2 of a thou small. And it's really easy in this job to get carried away with trying to make everything dead on perfect. And it's very easy to get lost in the quality of the measuring equipment. So we're gonna have to take a bit more out of this. So, and what you guys are gonna notice is the closer we get to 0, the slower we tend to move, because we don't want to overshoot it. So we'll set it back up and get some more machined. So after what feels like an eternity, Ross got bored and ended up sitting on his phone, because it was in and out with the mandrel. So in the first bit of footage, you saw us go from 5 thou down to, well, I can't remember, it was about an hour and a half ago now, down from 5 thou to, let's say, the 1 thou mark. And that all happens quite quick. It's then been about an hour of in and out, slowly but surely tweaking the way we move the mandrel, adjusting stones to get these all to the same size at the same time, bang on the 0 mark. So as we roll down, so you can see here where 0, there we go. And then what you find is, look, that one there, 0.2 bigger on that one. So what we have to do, we have to be 0.2 bigger on that one. Let's go to the other side of it. Back to the middle bearing. We're on 0. Maybe a tenth there. So, and then we have to go down to the other end and get that in as well. And you see we're on 0 here, and hold up, me and Ross are trying to work this out. Again, you're on 0 here, perfect. Again, we go to the next one, 0 there. So what we've got is we've got sort of up to a tenth or so over, and maybe a tenth under. Now, one thing we have noticed with these is, because you're honing on oil, not on water, temperature does happen in the block. So what we'll tend to do is now leave this for an hour or so before we finish it. That's really important. But other than that, the block is now done. Now, we've chose to go to bottom limit for the simple fact of, I can make the hole bigger very easily. I can't make the hole smaller. So what we tend to do is try to grind cranks to top limit, housings to bottom limit, and then when the engine builder builds that engine, we have room to polish a crank, we have room to open up the housing to get their bearing clearances and oil clearances exactly where they want them. Generally speaking, they'll be okay on the initial build, but for those of our customers that build engines to a really high level, where they're specific about the oil clearances they need, if they fit their bearings in order, trial fit their crank, and let's say they want a 2 thou oil clearance and they're getting 1 3/4 thou, I have some room in Jaguar's specification to make that bigger. And that's all part and parcel of the dry build process. Hopefully, I believe we've actually got a video coming up on the Ferrari 812, so you're going to see a lot of how dry builds work and all of the time and effort that goes into that. But on paper, this block is now done. I don't know. Right, Ross, can you come in here for the guys at home? Let me see if I can just wipe it, right? And you're going to be able to see that ever such a faint mark of the original machining in there. And then the rest of it is this beautiful honed finish, the beautiful honed finish of the main housing. Now, because it's not bored and it is honed, that's a really nice smooth surface. And what you're going to get is really good contact surface area on the shell bearings when you fit them, lots of heat transfer. It's a really good way to do all of this. So that, apart from leaving it for about an hour before I'd run a final measurement check, that block is now ready for us to pull off, wash off, and then it can go back to the mill for bore hone and decking. So remember, guys, if ever you're having your E-Type or Jaguar XK engine machined, this is a really important process that a lot of places either don't have the capabilities for or haven't had the experience that we've had. So I'm going to ask you guys one more time, if you can like and subscribe to the channel, it's greatly appreciated. And other than that, we'll see you next week.